Demand forecasting algorithms are developing rapidly, and choosing the optimal algorithm is no simple matter. Even 20 years ago, the predominant approach to forecasting was the classical method, which used sales history to generate a single number forecast without allowing for changes in demand. Let's take a look at different forecasting methods using the example of a garden. In the classical forecasting, the gardener calculates the average quantity of water needed to water the plants as a single number. This approach means that some plants will die due to excessive or insufficient moisture. Classical methods are simple to calculate but produce only rough estimates that ignore numerous factors, such as demand fluctuations and changing delivery times. For this reason, the quantile forecasting method was proposed. Calculations using this method produce an interval of probable demand instead of a single number. This method, however, employs an identical reserve stock model for all products. If our gardener were to employ quantile forecasting, he would calculate a watering interval that was suitable for a larger quantity of plants. By watering in this way, he would provide the plants with a reserve stock of water. Here, however, he fails to take into account that all plants are different. Some prefer very moist soil, while others are highly sensitive to excessive moisture. This is why a reserve stock of water must be calculated separately for each type of plant. Partial probabilistic forecasting lets us evaluate demand levels and their likelihood. In this way, we obtain individual demand distribution for each product. Now the gardener can calculate watering levels individually for each type of plant depending on its particular needs. This type of model requires significant computing power, so low probabilities are ignored. Advances in computer performance have made it possible to switch to a complete probabilistic forecasting model. Using this model, we can work with even the lowest probabilities and incorporate other significant factors, such as probability estimates of inventory and delivery times. Complete probability models help to determine where more stock should be held in reserve, and where a smaller reserve is more advantageous if sales probabilities are low and risks of inventory write-off are high compared to potential gains. For our garden, employing a complete probability model means that we can now calculate the optimal conditions for caring for each plant, taking even the least likely risks into account when watering and fertilizing. Therefore, at present, complete probability models are the most accurate for conditions of uncertainty and constant risk undertaken in business.